All right, well, happy Thursday and a welcome, Wolfram language and Wolfram technology enthusiasts. My name is Captain Timothy Newlin. I'm a captain in the United States Army. I'm also an assistant professor at the United States Military Academy at West Point, New York, where I have the distinct privilege of being able to shape and mold future leaders of character to become lieutenants and junior officers in the United States Army. It's with that perspective that I share with you today my talk about using Wolfram Cloud Forms in order to motivate math models in a remote learning, but also a hybrid learning type environment. And so many of us have found ourselves in different situations in terms of the way that we interact with colleagues, whether that's in the education environment or in the corporate environment. But one of the nice things about Wolfram language and Wolfram technologies, particularly with a lot of the cloud functions, is the ability to share information or visualize information for yourself and then be able to convey that through the internet in a means that is effective and also in a way that your students, your cadets, or your work partners, colleagues can then understand what you're trying to communicate. Because we are focused on optimizing for developing leaders of character who are good problem solvers. And so while I may have a particular passion for mathematics, that doesn't mean that all my students do. But I find that if I can tell effective stories, if I'm an effective storyteller and they feel like they've been brought into the story of how I might solve a problem that is important to me, that they're a little bit more willing to stick around for some of the math. And so one of the things that I've used in order to try and become a better storyteller is a lot of the graphics and plots in Wolfram language via Mathematica primarily. All of our students have access to Mathematica, and it's with that understanding that in a remote environment, yes, you could email certain notebooks, but it's a lot more effective and productive, I think, to either deploy notebooks or to create forms that then allow students to manipulate parameters or the values of certain variables and see what happens right on the screen in front of them. So that's what I'm focused on. I'm going to show you a few examples today. My abstract is that many students face significant challenges in visualizing concepts. That was true before the remote learning environment. It's all the more true now that we're sometimes distributed. I should say that sometimes I'm teaching students in class with a mask in a small section, socially distanced within the classroom, which has its own additional challenges. But some of the time I'm also on video chats in order to either convey information after the class is over, or occasionally some of the concepts that we use Mathematica or Wolfram language and other software products to assist in visualization may be taught entirely remotely. But all West Point cadets are required to take a course that uses math models in order to apply their problem-solving skills to real-world situations. And we focus on being able to take the real world, transform it into some sort of mathematical model that then we can solve. And often the tool for solving is Wolfram language, usually through Mathematica, and then take that solution, that math solution, and interpret it for a decision maker. And what we found is that a lot of times students grasp or jump at the chance to be able to use technology in order to solve something that they would have had to have done hand computation before. And the better that we can utilize that technology in order to solve problems, the more time that we get to spend interpreting the results, which is where a lot of the value comes in terms of being able to affect decision makers in terms of helping them understand what's going on with a particular situation. And so I'm going to show several different Wolfram forms that I created to help assist my cadets, my students who are mostly college freshmen, or we call them plebes, but college freshmen better understand some math models. We start off with different models, and we're focused at first on something called a difference equation, which is this idea of building a recursion equation where the result is based on some multiple of the previous result plus some other number. That's kind of our basic linear model for a linear difference equation. And together with the initial condition, we call that a discrete dynamical system. And we start with a single equation for the start of our course, and then we build to systems of those recursion equations. But in order to be able to describe and visualize and understand what's going on with those systems of recursion equations, we need some matrix algebra. And so we have a small section on vector operations and matrix operations before we come back to the systems of recursion equations. And so these are some of the things that we discuss in that class and that I've tried to visualize through these forms. So I start off with just a little bit of background. I won't go too much into the details of a linear discrete dynamical system. So you start with a recursion equation that we often call P sub n, and we say that given an initial condition where n often starts at 0, we can model the growth and decay or oscillation of certain situations and use those to model everything from the balance of a bank account to how much you owe on a loan, to the population of a particular species in an area, to the number of people who share or have received or recognized a certain message or idea. And you can begin to the number of customers. So with a Wolfram form, you can look at the Wolfram language documentation, but there are a couple of distinctions. You can run forms inside of a notebook, and then you can also deploy those forms to the cloud. When you use cloud deploy, the cloud deploy function in order to deploy to the cloud, then you've increased the capability for your colleagues or your students to be able to use the form that you've created. And so when I'm initially trying to tell a story, that's very important because if I can get a visual connection for you to understand what the output might look like, then you're that much more willing to stick around for, hey, how did he get to that solution? Or how did she come to this conclusion? Well, we can then name those form pages or those forms a particular object name and then just run the cloud deploy function on that object. So here what I've done is created a linear DDS in a form page. I should say that the distinction between a form and a form page is just with the form function, you create the form, and when you deploy it to the cloud, it goes on a website where the person can input the values into the form that you've created, but then when they click OK, the result appears, but they can't see anymore what they put into the form. Using form page I found is more productive for my students because they can look at the top of the web browser that I provided after I've cloud deployed a particular form, and they can see the inputs, but then they can also see the output. Now, within the form page function or the form function, there's basically two big pieces that are wrapped inside of the form function. The first part is where you define all of the different inputs that you're going to ask the person to provide. And that's what you see here. I provided an opportunity for them to describe. Now you can just put the name of the thing. I could have just said D, but by providing a description, like D is the parameter for the fixed amount of the arithmetic change to the recursion equation, or this is the amount that I want to add to whatever I had before. And then tell Wolfram language what kind of input you're expecting. Then you can begin to develop all of the inputs that you want them to provide. Now, you could choose to allow them to select colors on plots, or you could provide the distinct color in the form. It depends on what your use case is. But then after you come to the first part of the form, there's a comma that comes outside of all of the curly brackets. And the second part is your output. And so here my output was a column of different frames that provide certain computations based on the inputs. And the inputs of the form are those things that you see with the hashtag elements in front of them. So I asked them to provide a D value. I asked them to provide an A value. And then I provide different things in the output. Some of them are just feeding back what they provided, so they remember better what the particular situation was that they started from. And some of them are calculations like, what's the equilibrium value of this system? If we started at this value, an equilibrium value, then we would stay there forever. If we start anywhere else, we're either going to get closer to or farther away from those equilibrium values. But being able to visualize that better enables them to understand what happens when I change A, what happens when I change D. And if they can change those values in the form, then you're able to convey that concept more powerfully, I believe. So this basic linear recursion equation, the output's equal to some number A times the previous output plus D. And then you can also at the end, under the appearance rules, you could just leave this blank, or you can provide a title and a description. That's what I've done here. And so then once you run that in your notebook, something like this appears. And so then you can see that I've provided you with the opportunity to input all of these values. And then when you're done, you select the color and you pick the appropriate OK to submit that. Now, once you've provided all that information, here's an example. So in this example, I provided the A value as 2. So I'm going to take the previous output. So let's say, and this may not be the most appropriate, but let's say piece of N represented the number of Wolfram language users. So this is probably many, many years ago when Dr. Wolfram was first developing Wolfram language, but maybe at some point you started with 0 users, but then each time you doubled the number of users that you had the week before, if N represented weeks, or maybe it represented months, whatever you've decided to define the iteration. But you take the number of Wolfram language users in the previous iteration, multiply it by 2, because I've set A equal to 2, add a D value of 4 additional users separate from the doubling. Maybe the 2 was people talking to other people, but then people that had never talked to people who used Wolfram, there were 4 of them each iteration that also just somehow found out about it. So in that case, then what we can do is look at, okay, well, if I ran this for N iterations where N equals 13, and I wanted to know how many iterations would I need to run before there were 512 users, then I can put that information in, select the color of my plot, click OK, and I get some output that looks like this. Oh, okay. The equilibrium value is -4, so that doesn't have any practical sense in this particular situation. I guess if I had started with -4 users, if that was possible, then we would never spread the word about the language. But if I start with 0 and then I add 4 and multiply by 2, I can put the output in a table that gets rendered within the form. And you can run this on any device that has a web browser enabled because you've deployed it to the cloud. And so then you can also choose whether you want to make it public or private. If you keep it private, then you have to log in with your own ideas, your own Wolfram ID. If you make it public in terms of the permission, then you can share it with everyone, including your students or your colleagues. I should say that when you run forms in the cloud, there is a cloud service credit cost associated with some of that. And so you just need to be cognizant of that. But when you run the forms on your notebook, you can share it internally. And that's something you have to figure out for yourself. But here's the output. And we see that over time, the number of Wolfram language users would continue to grow and grow. And then you could also use this to represent a lot of other things depending upon what you're trying to model within the real world. But then how do you share that? So since I saved this as an object called linear DDS, I can then cloud deploy it. If I've deployed it before to a particular object and I want to update that and I haven't given it a human-friendly name, then I want to make sure that whatever I name that object, I put inside of here, inside of Cloud Deploy, and then it will write over that previous object with the update. And then if you set the permissions to public, then anyone can go in there and can input into your form. Now, this is valuable for my students who may want to visualize a linear DDS on their phone, but it could be valuable for colleagues or for customers, depending upon your use case. One of the last things you can also do within Wolfram language, I'll talk about, is barcode image. Now, you can create lots of different barcode images, but if you set one of the options to QR code and you take this previous output of the web URL as your input, and create a QR code, if you wanted to, assuming your screen resolution is high enough right now, you could point your phone at this screen on the QR code if you open up the camera application, and you would get a notification or an option that would, if you click on it, redirect you to the form that allows you to produce this linear DDS. And I did this with a student last week who was just slow to open and download the notebook that I had provided via one of our other email and other communication techniques. But when I put the image on the screen and he opened up his phone, and it was just instantly right there. Well, once I've engaged you with the form, you're that much more likely to actually put some information into it and then get some value out of it. So I'll go through a couple more examples before I open up for questions, but the form or the structure is similar. So you could use this to build a form that visualizes network flow. So this is one of the topics that we talk about in some of our matrix applications besides systems of recursion equations. And so I've created a form that allows the user to input a bunch of different information about their particular flow network, where you have nodes that represent certain spots along the network, and you could be pushing things through them. They could be 30 messages in this example, or it could be 30 packages, or it could be 30 people. This could be a transportation network. So there's a lot of different things that you can do. With this form, I can change the name of my plot. I have it set up so that you provide an edge list, and then it produces the graph associated with it of that network, and you can add the weights in. But you could create a similar form that took an adjacency matrix in order to convey the network. And what you see here is these are unknowns. I've put in strings, and then this allows a cadet to look at a particular system and say, okay, well, if there's 30 going in, there better be 30 coming out, but I haven't been given any more information yet to say what these other values might be. So I'd have to provide them with more information if I wanted a specific solution. All right, some of the other concepts related to vectors are how do we add and subtract vectors? And I should say that some of my cadets have a lot of background experience in math in high school. Many do not. And so they may have had some exposure. They've definitely had some exposure to algebra, geometry, to trigonometry, but not everybody's had calculus. And certainly many people have not seen vectors and matrices. So we start off with addition and subtraction, but adding and subtracting numbers isn't nearly as exciting as, at least for a lot of people, as adding and subtracting objects or manipulating objects. And so we talk about how a vector can be a list of numbers that has a certain dimension to it and represents a lot of potential things from the real world, but it has a magnitude and a direction. Okay, well, if I can show you something that actually has a magnitude and a direction, and then if I use color to help to distinguish between what I'm adding to what, then you're that much more likely to understand visually at least what's going on in 2 dimensions. And so then when we start adding things in 4 or 5 dimensions with vectors, then you're a little bit more likely to have some appreciation of what's going on. And so here, this form takes 2 vectors that you provide, in this case, the vector 0, 3 and the vector 4, 0 with the standard basis vectors. And when we add them together, it produces this purple vector. So then I can talk about to a student who can see on their phone with a barcode image or click the link if they're over a video chat with me about how we're adding the tip of the red vector and taking the tail of the blue vector and putting it there, and the result is this purple vector. And then, hey, this is the magnitude, but this wasn't magic. This was Wolfram language in Mathematica that I had to provide in the previous part of the form, the formula that calculated this 5, or I had to provide the angle. Now, depending upon your purpose within math class, you may decide to gloss over the particulars of a specific formula, or you may decide to go into more depth and detail about that formula because you think it's important. But the nice thing is the form allows you the flexibility to decide how much detail you want to go into describing particular concepts. Okay, I want to briefly mention another topic. We talk about matrix operations. And so I built a form that has similar types of setup in terms of first you provide the information. And this code is posted in the notebook that is on the Pathable site if you are logged in. So you can look under the Files tab and download this for yourself if you desire. But there's the inputs, and then as you go further down, you're provided with the opportunity to see what the outputs are. Now, what it asks for is a transformation matrix, A, and then the vector that you wanted to start with, X. And that's the way I'm trying to describe it to my students. And then I say, hey, you pick the color. And they say, okay, sir, we'd like to take an orange vector and turn it into a blue vector. Okay, and I say, well, the orange vector is the vector that goes 3 units in the X direction and 4 units in the Y direction. Now, what's going to happen when we multiply it by this transformation matrix where the first row is 2, 3, the second row is 1, 2? Well, if we run the computation, we see that the orange vector gets pushed a little bit down and to the right, but it also gets a lot longer. And then we can have a conversation about what it was we were trying to represent, whether 3, 4 was a particular pixel on the screen that you might be staring at, and I took the color of the little square that was at the tip of the position vector, that's the orange, and I moved it because of a transformation that I wanted to do with image computation on images, and I moved it over to the spot that's now where the tip of the blue vector is, and so whatever color was on the tip of the orange is now at the tip of the blue after this transformation matrix A. Or we can talk about rotation matrices, and then they can see it. And through repetition of changing the values of the matrix A or the vector X, they begin to more easily inculcate the relationship between the input and the output, which is one of the goals that we're trying to do in terms of being able to solve additional problems. All right, we also fit functions to data in the last part of our course on modeling. And so there are some built-in functions that definitely have a lot of use from the Wolfram language, but sometimes we want to start by reminding people of what these functions look like and then discussing, okay, well, what do I change in this parabola, this power function that makes it a parabola? Or what do I change that causes it to get shifted to the side horizontally? What number did I change in order to get it to shift vertically? And so that's what this form was designed to do. It takes an input that corresponds to this form of a power function, where I'm taking X and raising it to a power B, multiplying by A, adding a vertical shift D. And then I've also provided the opportunity for them to adjust the X plots. Now, could you do all of this in Wolfram language by studying the plot command? Absolutely. But if I want to get them from the start, then the form allows me to do that, especially if I've deployed it to the cloud, because they can pull it up on their phone when maybe they're moving. They got 10 minutes between a couple of classes and they know they need to do a little bit more prep before we talk about this in the next class. They have the flexibility with the cloud deploy. All right, now that I've talked a little bit about some of the things that you could do with forms, I want to highlight just quickly what's some of the output that you may choose to use or other techniques that aren't necessarily the form themselves. So something that I did, because computation is not just about mathematics, but it applies to computational thinking, a lot of different disciplines, is this is kind of an extension of the computational photography, but hey, we could build a PDF slide of some of the plots that we created with our math. And wouldn't it be nice if you were trying to create a bunch of different example problems, if you had already built kind of the structure of your slide, and then you were just able to provide the specific computation for maybe even randomly generated vector of problems to solve. And this might provide you with that ability. So what I first did was define a function in Wolfram language that takes a plot, some text that I want to put in the left column of the slide, and a title. So I put the plot on the right-hand side. And then you'll notice that this is just a nested image composition, so the image compose function. And I have provided a slide for kind of a standard West Point teaching slide, but you could provide your own slide as an image inside of the function that you create. Save that function, run it, and then create your input. So here I did a linear DDS that involved 2% interest. So I take the previous amount, multiply it by 1 plus 2% or 1.02, and then I assume that the person puts $90 into their account each month and they started with $25. I ran that, and then using the table command, got a bunch of outputs for, after so many n iterations, what's the difference between the previous iteration and this one, and what's the actual current output of the account? And then I put that into some text that I turned into an image, but you don't have to, it's your choice. Then I built the plot. What does this look like in terms of the output of that table using the list plot command? Then once I had my plot, I put them together into the slide by just running my slide function with the input of the slide plot and the text table and the title that I put in there. You could put whatever text you wanted in here, and then you can quickly create your slide and export it as a PDF or any other image format. Finally, I didn't do this because we have a learning management system software available to us that we're encouraged to use, but if I was working remotely, with students and I didn't have the advantage of some of those resources, you could also use Wolfram Language and the Cloud Deploy to deploy a notebook that was styled like a web page to the cloud. Cloud Deploy the notebook. Now, you can use the Cloud Deploy or Cloud Publish function within a Wolfram notebook, or you can, if you're working in Mathematica in the desktop version, click on the File menu and then come down to the Publish to Cloud, and it will provide you with the URL for the place that you published it to. So you got some flexibility there. An example that I provide here is at this particular site, again, if you were to point your camera at this QR code, it would redirect you to this web page that has a Wolfram notebook with some hyperlinks inside of it and some additional text and an image that I created of a map using some of the newer geographic functions with geographic plots. Anyhow, my basic point is that you can use Cloud Deploy, you can use Cloud Publish in order to better share your ideas with your students in a remote learning environment, but also with your colleagues. And so an example of doing that within the learning management system that we use, I was able to use the embed code function that's built into Wolfram Alpha, and it provides me with the HTML language that I can just copy into one of the items in our learning management system, and then it automatically imports my form. So this form was designed in order to allow students to visualize what a 3D plane was based on a parametric equation. I'll take whatever questions we have with the remaining 5 minutes or so. Thank you very much for your time and attention.
There are a couple of questions on the Pathable chat, if you wanted to take a quick peek of that.
Ah, yes. Okay. So yes, the highlight about form versus form page. So that's helpful in terms of, again, depending upon your user and what they might be interested in. The form page allows you to see your output and input on the same side, the same site. And yes, so comment about Cloud Publish. I've only used the Cloud Publish once, but that's a very good note. And I might be using that more often because most of the stuff that I do is stuff that I'm just as happy to share with the rest of the world as I do with my cadets, although I think it's mostly the cadets that are interested. How much do we discuss Wolfram language syntaxes in the class before introducing form pages? So I'll say that first, I'm one of a few people that actually use the forms and form pages in terms of sharing the Wolfram language with my students. A lot of other colleagues, everyone uses Mathematica and the Wolfram language itself, and the syntax of some of the basic functions is kind of the introduction to our discussion about matrices. So it's kind of one of those things where historically the basic recursion equation, when it's just by itself, we've been able to describe to students pretty well in Excel, but I use it as an opportunity to start with the table command and show some of those recursion equations in Mathematica, because I feel like the earlier that I start exposing them to some of the Wolfram language, the less of a learning curve it is when we actually need it more when we start working with matrices. And so we're fortunate enough that some instructors choose to use the palettes a lot of the time in order to avoid delving too much into the particulars of, hey, there's a curly bracket here and a square bracket here. But for, it's kind of an instructor decision, I guess, is the way that we've handled it. But students have the ability to use Mathematica on certain assessments and not on others, depending upon what it is that we're trying to assess. And so the students who are more comfortable, the way I described it to some of my students last week was, how would you like to have 10 less minutes on our next exam? And nobody raised their hand. I said, well, you know, if you don't take the time to learn a few of these basic commands, or at least get familiar with the documentation so that you can run them, even if you can do some of this by hand, it's going to take you a little bit longer, because we designed the exam with the assumption that you knew how to use some things in Mathematica in order to solve this particular type of problem. And so that gets some people's attention. How often do students ask about the code behind the scene? So that's the danger of, I think, the form is the oversimplification, and that, okay, it's like magic. We got this solution, but we don't necessarily know where it came from. And the nice thing about the appendix in our textbook is that some of the previous instructors have provided more detailed examples of some of the code. I just like to direct my students, because a lot of times it's hard to get them back into the textbook, but use the question mark, and then the name of the function that you're looking for, and the built-in documentation will pop up with some examples if you're using the desktop version. And you can go through those examples and get more familiar with the syntax. So we kind of leave it as an individual choice for the students, how detailed they want to get with it. But those who delve in a little bit more find themselves with a few extra minutes to go back and check their answers on certain assessments, and they find themselves with a slightly better polished product if they've used Wolfram language to help produce a report for a project. High school student, I found your talk is a good summary. Thanks. Thank you as well. Is there an informal Wolfram language special interest group among professors and students at service academies? I'm not sure about that. I don't believe so formally. I know from time to time there are communications between some of the service academies, and there's a journal that professors and students can submit articles to from the different service academies as well. But beyond that, I don't think there is much of a cross discussion. I guess I should say that I know there was at least some amount of cross discussion, particularly about the topic of the licensing contract, but I was not involved with any of the particulars. I just know that one of the considerations is making sure that we renew our license each year. Anyhow, I appreciate everyone's time and consideration and all the great questions. I hope I was able to address them. And thank you very much for your time. I think I'm out of time.
We can go a little longer if there are any questions, but if there aren't any others, we can end the session.
Yeah, I guess just to follow up on the bit about the code behind the scene, I found a variety of different students. So I had one student last semester who was really into some of the particulars of using Mathematica and Wolfram language, not just in his class for the calculus course he was taking, but also to better describe some of the solutions that he was trying to get to in some of his other classes. And so he wanted to do things with animation and videos. And so he was very willing to delve into the details of some of the code. Most of my students are kind of content once you show them row reduce on an augmented matrix to just kind of say, oh, okay, this is the function that I use for this particular situation. This is the tool. And now I just need to make sure I know how to put a matrix in. But I found that if you show people a couple of different examples, that we get kind of a mix, and then you can also start to tell what some people's particular academic interests might be, and those who are more into some of the engineering and sciences tend to be the ones that want to go ahead and revise some of the code themselves because they weren't satisfied with the output. And that's what I got. Thank you very much for your time. I hope you enjoy the rest of the conference.